All right, welcome to the lesson for factoring polynomials completely. We're going to start by looking at these three trinomials. So let's look at the first one. We're asked to factor it. So the first thing we should do is look for common factors. So we have 3 x's and a y, an x and 2 y's, and an x and a y here. And then there's a factor of 2 in each of these. So I'm just going to do 2 times 4 times x times x times x times y minus 2 times 5 times x times y times y times y plus 2 times 11 times x times y. So we have a 2, an x, and a y in common. So we're going to pull those out front. So we're going to get 2xy, and what's left in the first term is 4x squared minus 5, there should only be 2 y's there. So there's going to be 5y here plus 11. All right. And by looking at this, we can see that it can't be factored anymore because there are no more common factors. Sorry, I'm just going to erase that so I can do this one. So in this one, we looked for common factors. Now here, there are no common factors. Does that mean it's already factored? No, because we remember that we can break trinomials up into the sum of 2 binomials, okay? So this first term is the product of the first 2 terms of these binomials, which has to be x and x, because x times x is x squared. Now I'm just going to use our pattern. So I know the next 2 numbers have to multiply to -6, but add to -5. So I'm just going to factor this real quick. So just 1 and 6 and 2 and 3, right? But one of these have to be negative, so that means there also has to be their opposites. So this equals 5, this equals 1, this equals -5, and this equals -1. All right, so we're looking for -6 and -5. So we want 1 and -5. So x plus 1, x minus 6, right? So now this is factored. Now let's look at this last one. Are there common factors here? Yes, it's 2. So 2 times x squared plus 7x plus 12. So I just took a factor of 2 out. So now there are no more greatest common factors inside this, but can this here be factored in the same way that we factored this? So actually, let's just go back. So this one we looked for common factors. This one was product of 2 binomials. Okay? So here, the first thing we did was find common factor. But is it factored completely here? I'm going to go ahead and say no. Okay, because this trinomial can still be factored. The same reason that we have an x and x here, there also has to be x's and x's here. Same thing. Let's factor 12. 1 and 12, 2 and 6, 3 and 4. All right, and what do these add up to? 13, 8, and 7. All right, and we want that 7 one, so we're looking for x plus 3, x plus 4. All right, so here we got 3 terms. So first we find common factors, and then second we break into product of two binomials. All right? So if this one doesn't make sense, let's just look at a number example real quick. If I was asked to factor 40, and I factored 40 into 4 times 10, is this factored completely? No, because both of those can be factored more. This can become 2 times 2 times 10, or it can become 4 times 5 times 2, or it can even become 2 times 2 times 2 times 5, okay? And so we have to keep factoring down. Now, 2 times this trinomial is equivalent to 4 times 10, and the 10 is this part, this trinomial. So we have to break our 10 into 5 and 2 in the same way that we broke this trinomial into these two binomials. Okay? So let's look at a few more examples. Let me just write the steps, though, for factoring completely. 1, look for greatest common factor. 2, if possible, break remaining tri or polynomial into product of two binomials. Okay? So let's just look at this one here. 4x squared plus 4x plus 12. So the first thing we're going to do is look for greatest common factor. So we have a 4, 4, and 12. So our greatest common factor is just going to be 4, because 4 times 1 plus 4 times 1 times x plus 4 times 3. So we have that 4. So we get 4 times x squared plus x plus 3. So now our next step is to break it into two binomials. So we already know it's going to look something like this with an x term here and here because of that first x. So now we just have to factor 3, 1 and 3. So these are the only factors. I guess it could also be -1 and -3. So 1 plus 3 is 4, -1 plus -3 is -4. 4 does not equal 1. -4 does not equal 1. Okay? Because we want it to equal the 1 here to follow our pattern. So there is nothing that adds to 4, so we cannot break into product of two binomials. So the answer is this. But we have to check first. We first have to check if possible. Okay? Because we don't necessarily know that x squared plus x plus 3 can't be factored anymore until we try. Okay? And sometimes sometimes there is no greatest common factor, but we still have to break it into two binomials. Sometimes there's only a greatest common factor and we can't break it into two binomials. Sometimes neither can happen, sometimes both can happen. So we're going to look at one more example and then you should be good to move on to your handout. So 5x cubed minus 25x squared plus 30x. Okay? So we have a 5 and an x term that we can take out. as a greatest common factor. So we're going to be left with x squared here minus 5x plus 6. Okay? So now we're going to do, so that was our number 1. Now we're going to move on to 2. Let's factor 6, 1 and 6, 2 and 3. So this is going to give us 7, and this gives us 5, right? But again, I said it can also be negative numbers, because a negative times a negative is a positive. So negative 1 times plus negative 6 is negative 7, negative 5. So we want those ones. So we're going to get 5x times x minus 2, x minus 3. Okay? All right. You should be all set to move on. Remember, you already knew this lesson. You already knew how to find the greatest common factor, and you already knew how to break it into the product of two binomials. This lesson just combines both. So now you have to do both at the same time like we just did here.